This video will present an example of two Anova factors. First, we need to review what is an Anova factor. Anova factor is a statistical test that shows you how the variables or factors are related with a responsible variable. We have an example. An engineer is designing a battery that will be exposed to extreme temperature variations. The engineer wishes to know which is the material that resists better to the temperature changes. A test is concluded to see which is the best material to make the battery. We need to define which of the data in this table represents the response variable and the factors that we are going to study. Battery life represents the response variables. Material type and temperature are the factors, and we have three levels for each one. Of material type, we have 15 degrees, 70 degrees, and 125. And the temperature we have, no, we can correct. Material type, we have material type 1, 2, and 3, and temperature we have 15, 70, and 125.
Our response variable will be the battery life. The test selection. We select the wave factor analysis of variance because we have two factor and three levels. And well, the objective of the experiment is that the experiment will show which is the best material to take to make the battery. The established hypothesis. H0 will be M1 equal to M2 and equal to M3. And H1 would be at last one pair of is different.
So then, to establish the hypothesis, we introduce the data in Excel and save it like a text. Then in R, with the function read table, this, we introduce the name of the Excel file, and then we have to appear the data in a table. Then we have to construct the model. With this, we put the dependent life, that is treat life, and then the dependent variables, material type and temperature, and obtain the summary of the model. In the step 3 and 4, we have to calculate the statistic and the test statistic and the p-value. So we have to analyze the summary of the model, that it is this table. So here appear the p-value of material type, the p-value of temperature, and the p-value of the relation between the material type and the temperature. So since p-value of material type and temperature are smaller than the alpha, that is 0.05, we have to reject H0. Then we can conclude that means are all different and they have an impact in the battery life. But there is not a relationship between the material type and the temperature.
The temperature and the material type affect directly the battery life. Thirdly, depending on which material and temperature, it will change. In this case, we can recommend to use the material type number 3 to enlarge the battery life, because we can use any temperature and it will work right.
So for the general conclusions, we have to analyze these two tables, two graphics, the material type and the temperature. So we can see that the material type 3 is the best, and the temperature, the best is 15 degrees, but The temperature, it doesn't matter because we can control it.
To obtain the means graphs, we plot the means with a function, with this function, and then we plot the model.
So the final step is the normality test. This is to validate our conclusions, and we need to make the Anderson test. So with this, the p-value is 0.48, so it's smaller, so it's bigger. And in the graphic, we can observe that the data follow a pattern like a function. This. Then we have to do a data transformation to correct if the media is not constant. Then we plot, or we did the cuckoo plot, and according with the assumptions of two-way Anova, this experiment fulfilled with the normal distribution.